So hello everyone. My name is Roy. I'm a security researcher at Abdom, and I was leading one of the development teams that we have at Abdom. Right now I'm a solution architect and customer success engineering lead. And I'm going to talk today about accessibility service malwares. So just like a small note, like a few years ago I was dating this American lady, and she told me that Roy is like an 80 years old guy name in America. And so if you were planning on seeing like an old guy here with no energy or nothing, then yeah, that's not me. All right. So before we go into how the malware works, let's get into the boring stuff and the necessary knowledge before. So we're going to speak about two attack vectors. First attack vector is credential stuffing. So this attack vector is basically infecting devices, mobile devices, Android devices, and it's attacking the server using the infected devices. So basically what is happening here is that we have a client that was infected with a malware. We have here the WAF, Web Application Firewall, which sometimes does IP filtering, mutual TLS, user agent validations, and we have the server. So basically what would happen here is that the infected device would get some combo lists from the server, some username and passwords it would want to try. We will speak about how can we get those usernames and passwords later. From the C2 server. C2 server is basically command and control server. Now, basically this server gives the combo list to the device. The device is then sending the HTTPS request to the server. Now, it bypasses all of the IP filtering, MTLS, and user agent validation. Why? Because it's not like a regular C or RL script. It's the actual mobile application embedded with the exact API that should be used with the server. And then it attacks the server, which then can get lots of requests because we are speaking here about botnets. It's like hundreds of thousands of devices that can try and attack the server simultaneously based on the C2 server that says them, all right, we are starting right now. Yeah, so how do we get the user password combinations to try and get to the server? So there are many ways to do that. First way is using Telegram. Telegram has many combo lists of username and passwords that were exposed during, I don't know, like hacks to some companies, to some banks, to some insurance companies and stuff like that. So we're going to take those combo lists and using the malware, try and attack the server. Now the nemesis of this attack is achieving an account takeover. Account takeover is basically when my combo list got me like an access to the actual account, and then I can basically do whatever I want to the account. If it's a bank account, then congratulations. I hope they have a lot of money in the bank. So that's the first thing we can do. Second thing is a simple brute force. I can just like random some username and passwords, and when I have like hundreds of thousands of devices, I'm going to distribute all of the work for many of the devices and try and attack the server simultaneously with many of them. And it can work way better because I have tons of computing power. Third thing, which is my favorite one actually, is human. Human is human intelligence. So who here has a dog? Someone here has a dog? Yeah, don't use it as a password, okay? All right, now about the big letters. So we have two ways of credential stuffing attacks. The centralized credential stuffing and the decentralized credential stuffing. We are speaking now about the decentralized one. Why? Because we have real device properties. We have real past session with the apps. We are bypassing the detection, as I was discussing earlier. And the main cons is the infection, which we will discuss later. But the thing here is that it's way more hard to infect a device with this kind of malware. The centralized one is basically what we call a bot farm. A bot farm is basically a machine or a few machines that runs Android emulators, and using the emulators, it's gonna try and attack the server. Now, the thing with this one is that you have the direct control of the devices, which you can just use ADB or something like that in order to perform the attack. You don't have to do an accessibility service. You don't need to hide from the user because you are the application itself. The device itself. The thing is that you wouldn't have the device validity. So while it would work with the MTLS and stuff like that, the IP filtering might just block the IP that you are trying to attack from. And the second thing is that many modern applications nowadays have an emulator detection, a quite simple one. And then I'm just getting all of the air out of this attack. Again, the accessibility service malware is a decentralized one because it can come from all over the globe and just attack from all over the globe. So, yeah. Now we're going to talk about the second attack vector. The second attack vector is way more complicated and way better for the attacker. So if the credential stuffing one is attacking the server, then this one is attacking the actual client, the user itself. And I'm going to just show you a video of it, which I think will help me demonstrate. So we have here a banking application from Brazil. This was posted on Twitter. This is like public media. As you can see, you have here some money in the bank. And what the user is trying to do right now is transfer money to someone. So as you can see, he's going to transfer now. He's going to transfer $1. Remember this name, Raimonda something, okay? Now, you can see here that we have like kind of a spinner. Let me know if you see something different in the device right now. Maybe someone noted something pops up here. And then it asks for the PIN. Now look, we go back, we see it's not the Raimonda that was earlier here, it's Wesley, and it's $600 now. It's not $1. So that is done without the user knowing anything. Now, we're going to discuss later how this is being done using accessibility services. Just a bit about the literature. So many of those malwares are well known in the media. One of the most known one is Xenomorph. So it has hundreds of thousands of infections. It's trying there are like a few hundred of vulnerable banks, mostly banks and financial institutions that are vulnerable to this attack. There are way more, like tons of them. Like it's a business. This is how you make money today. Yeah. So once the ATS malware obtains the relevant permissions, it infects the device with the Trojan. Yeah. It establishes the connection with the server, receives the scripts from the backend, which we will discuss later, and then it can just perform all of those attacks, the overlay attacks, the steal session cookies, and automatic fund transfer, which is what we just saw. Just a small note about how do you infect the device with the Trojan. So first, when you use an accessibility service, you need an application to host you. Yeah, as the application that contains the accessibility service and bind it to the system itself. Now, many applications are trying to say that they are doing one thing, such as call recorder or auto cleaner for your Android device, which basically behind the scenes, what they are actually doing is writing a malicious accessibility service in order to try and obtain permissions and then perform some attacks. Now, the funny thing is that accessibility service can basically do anything on the phone. It can read the screen, it can click the screen, So if you gain them the permission of clicking the screen, the first thing an accessibility service would do is the second they can, and you do not see that, they would obtain themselves some more permissions that they would then use later, such as reading the SMS messages and stuff like that. All right, so we have seen in the video also the overlay attack. So you think you are transferring 500 to someone, you are transferring it to someone else, and in the transaction overview, you would see that you have no money left. So now let's speak about some legal obligations. We're going to talk about the Americans with Disabilities Act. That's basically an organization that is going after institutions that develops applications in order to make sure that people with disabilities, such as blind people, are capable of using the same goods as people without disabilities. Why this is important? Because Android is enabling the accessibility service framework for those kind of people. So you cannot just block all of the accessibility services because they will sue you and you will need to pay lots of money. Same in many other countries like South America, I think, and also in Europe. There are regulations here. So businesses are required to support the usage of accessibility service within their application. You cannot just block it all. Now let's talk a bit about accessibility services. So that's basically the attack framework. This is the attack surface, how we perform this attack. So again, this comes to help users with disabilities and make sure that they have everything they need in order to use their devices the way they should, yeah, like all of us. So it has its capabilities, it has its permissions, et cetera, et cetera. Let's just go over one of the capabilities. So it can read whether the window content has changed. We have other things here, like perform screen gestures, which basically means they can touch the screen and change stuff on the screen. Yeah. All right. Now, for the fun part, I'm going to say before I'm going to this part, responsible disclosure. This is for educational purposes only. Don't try it at home. All right, so the first thing we'd need to do is inside our hosting application, we would need to bind accessibility service permission in it. Next thing would be, I want to start my accessibility service. So on the service connected, I'm going to make sure that the info or the permissions I'm asking for are the relevant permissions in order to perform this attack. Now, regarding the flags, so this one basically means I want all of the data you can give me from the device. And the last one here, the info package names. So as an accessibility service, you can decide that you want to interact only with one application. But when you put in the package name null, someone can guess what would it give me? All of them, right? Okay, so now we're going to start launching the victim app using the accessibility service. So we're going to have a launch intent with the victim app package name, the class, the activity that is going to be launched on launch. Yeah? Set the package, and we're going to just start the activity. Now we have the application running. Now, what we're going to need to do is, this is one of the callbacks that you need to implement in your accessibility service, which is called on-accessibility event. And then we're going to just want to filter. We don't want any accessibility events from other applications. So if the package name is not our victim application, then we're going to return. If this is actually our application and we got into this actual activity, which is the login activity, then the login has reached and we want to mark it for later. Now basically, how do we get into the login page? So you can use something called accessibility node tree, which basically means I'm going to take one or all of the objects on the screen and just iterate over them using BFS, DFS, no matter like which algorithm you want to use. And then I'm going to get all of the views and all of the buttons on the screen, on the window, and basically that's it. I'm gonna have it all. Yeah, so this is the way we're gonna iterate on that, because we wanna get all of the nodes in the tree. Now we're gonna find one of the buttons that leads to the login, the fastest way. Here it's the go to card button. Now we're gonna speak about something called accessibility event chaining. So that's like a big term, yeah? So what it basically means is that we can have an action, then it would have an effect, and it would come back to us for another action and another effect, kind of like a butterfly effect, but in Android applications. So we had no activity on the screen, then we launched the activity. After we launched the activity, we can see that the window has changed, yeah? And we can get the class name of that. Then we're gonna perform the action of going to the cart, and again, the content changed event. And then we have arrived into our login activity. Next thing we're gonna do is enter the login details. So we're gonna put the mobile number phone, the mobile number or the email, or it doesn't matter. Then we're gonna put a password we would wanna put. And we have one last thing left, clicking on the login button. Now, that's like what we wanted to achieve. Now, Android, as you know, hardened, like many releases ago, the option to perform actions outside of your process. Now, using the accessibility service framework, we basically managed to bypass all of that and to run some stuff outside of our process and attack the server with it. So when I was doing some testings, like a few years ago when I developed one of those features for Abdom, I managed to run 5 to 7 login attempts per second. Now, think of 500,000 of devices infected with this malware trying to attack your server. Not a very pleasant thing for the DevOps team, yeah? All right. So it's not that we can just attack one application. What can we achieve here is when we have our C2 server, command and control server, we're gonna get all of the details of how do we get into the login page or to the actual page we wanna attack. It can be, by the way, an ATS. It doesn't have to be a credential stuffing. Like the current example is for credential stuffing. We're gonna get the application package name, we're gonna get the path, we're gonna get the combo lists, and then all we need to do is run the attack. All right, now I wanna ask you a quick question. I wanna hide myself from the user. I don't want the user to know what I'm doing, yeah? What can I do? Someone has an idea? Sorry? I want to hide the service. I don't want him to know that I'm doing something, because currently, like if we'll go back here, yeah, the login page is on. He's gonna see that if he's looking at his phone. I don't want him to know. What can I do? Overlay is a good idea. Something else you can think of? Yeah, that's overlay. It's showing a screenshot of something. This is what we have seen in the video, if you remember, of the spinner. So that's basically an overlay trying to cover for that. This is one of the things that those malwares are doing. We're going to discuss a few more things, so think about it. Can you see what's happening on the phone when it's upside down? No. So that's a very good idea to start the attack when someone is flipping the phone to the back. Yeah. So orientation sensor manager is basically something enables me knowing that whether the device is facing up or down. Now I can just read that, yeah? And accessibility service has the option to do that. Then what we're gonna do is we're gonna take the type of the event that we got. We're gonna look at the gravity Z1. That basically means which way the phone is facing. If it's facing up, we're going to show this screen. We're going to close our activity. If it's facing down, this is what's going to be on the screen. All right? Now, that's not enough because we want to keep the device awake. What if the device wouldn't be awake? Yeah, it would fall, like close in in a few times. So yeah, we have a solution for that as well. We can just use the wake lock permission, yeah, which basically means I can just keep the device awake for as much time as I want, as much time as the attack is going. And the last thing is, like you guys said, the overlay thing. We cannot take the risk as a malware that out of nowhere the user would flip the device that fast. We wouldn't have time to read everything, to close what we are doing. So we want to show an overlay, just something that he would see. So a screenshot of the actual applications in the phone can work. And we can just put, welcome back. We are logging you in for a lot of time. So yeah, it's quite easy. We just need to infect a lot of devices. All of the devices would be legit. It's the decentralized credential stuffing. Yeah. We have the ideal masking. No one can know, no one can find our computing power. The computing power is anywhere, yeah, anywhere in the world. The matching combos would get me some information I can sell online afterwards. That's easy money for attackers. That's again the Americans with Disabilities Act. So, as you can know, they have sued many organizations, amongst them many of the banks. We are entitled to provide the permission for the users, sorry, not the permission, the usability of the application for the users. So we cannot just blog it all. It's also titled in the second Americans with Disability Act rule. So it's basically, we cannot, that's a very, very problematic situation. And now to the last screen. So who doesn't know ChatGPT? So I went into ChatGPT and I explained him the situation. And I told him, hey, ChatGPT, please provide me a picture describing that. Now that's the picture that he was describing. So as you can see, we have like a courtroom here. On one side, we have the accessibility and usability for people with disabilities. On the other side, we have the security that we want to enable in our application. And here in the middle, yeah, so that's like a poor developer that needs to understand how to do that. It's not that easy. It's a very complicated task. Yeah. All right. I'm just going to roll back for a second and speak about what Android is doing in order to improve the security of those accessibility services. First thing, starting from Android 12, Android added a permission that you can grant your accessibility service. You would need to get the approval of Google, but you can get something in the metadata of your accessibility service saying, I was granted the permission by Google to help users. Yeah? I'm not just any accessibility service that was installed from an application that is not from unknown source. It can also come, it can only come from Google Play, and if I have this permission, it basically means Google approves me. So that's, for example, is an accessibility service I would want to be used in my application. The problem here is that many of the users are not using the accessibility service from Google Play and using some unknown accessibility service from somewhere else. The second thing that Android did in order to improve that, starting from Android 13, if I'm not wrong, there is an option to block overlays in specific activities. You can read about it, and if you'll use that, it would basically mean that those malwares inside your Android application cannot do that. Now the thing here is that it's quite complicated to implement all of those things because you would need to get to catch all of your views and make sure that only the views that cannot be shown with overlay on top would have like this exact permission. Now you can try and implement that yourself, but that's a very complicated task because you would need your heuristics and you would need to understand how you're going to do that. Second thing you can do, which I think is way better, and that's basically what pays my rent, yeah, is go and use tools like AppDome. So AppDome is basically a unified platform. It's a one-stop shop for mobile app security. When one of the things that we are doing is that we are protecting against all of those malwares that I've shown you. I would have said, come check our booth out, but we just closed it. So you can go to appdome.com and read all about that. We enable all of the options, such as granting the permission only for Android, such as blocking the overlays, and we also have some detections that are capable of detecting specific applications that we know what they are doing, we know what the permissions are. We can detect xenomorph that I showed you earlier. We can do lots of stuff. That's it.